I remember this brain cramming exam I had back in high school. I had spent a couple of afternoons reading likely questions, hiding the answers, and repeating them in my head. Of course, after the exam, I made sure to press the reset button in my brain to make room for the next rote memory exam that was coming up. I did good. I memorized a few things, sure, but did I learn anything? Nope. Agreed. The subject matter was probably not very relevant to whom I was back then, but relevancy alone cannot explain why this information, committed to memory, failed to stick. My brain remembers a ton of relevant and irrelevant things for which I didn't study. Why is that? Well, I think it's because my goal was not explicitly to remember these things, but rather to do something interesting with them. I was probably analyzing, evaluating, or creating stuff when it gelled into memory. My colleague and I came up with an explanation to this using Bloom's taxonomy and Vygotsky's zone of proximal development, and we think it could be very useful in the classroom. Would you like to hear it? A few decades ago, Benjamin Bloom led a group of researchers that came up with a very clever way of looking at learning, which is still very relevant today. In this model, there are 3 different categories of learning: the cognitive, the affective, and the psychomotor. Some call them the head, the heart, and hands of learning. In education, we tend to focus on the cognitive domain, the head. There are 6 levels of educational objectives in this classification, better known as Bloom's taxonomy. In 2001, this was revisited by Lauren Anderson and David Cratwall, and now it looks like this. Drum roll, please. Remember, understand, apply, analyze, evaluate, and create. Pretty straightforward, right? Let's divide this thing in 3 sections, bottom, middle, and top. We feel that remembering, understanding, and applying are pretty close cognitively. They're also somewhat mutually exclusive. I can apply a process I don't remember, like reading the same recipe over and over again. Some remember things they don't understand, like knowing the words to a song or prayer, while never really understanding their meaning. You can understand something that you never apply, and so on. These levels of educational objectives are often referred to as the lower order thinking skills, or LOTS, hinting at the fact that a majority of traditional learning activities dwell here at the bottom of Bloom's taxonomy. You might have heard of the HOTS, the higher order thinking skills. These would be the top 3 levels of Bloom's taxonomy. I like to divide the top 3 levels in 2 groups. Analyzing and evaluating can be so similar from a classroom standpoint that we might as well consider them as one. I feel creating merits a category all of its own, since its inherent strategies and processes are so very different. Can you notice a progressive complexity from bottom to top? Great. But there's a trap! This does not mean we should start by memorizing before eventually creating. It does point to the fact that the LOTS are less demanding and engaging than the HOTS. Not that you should master one before tackling the other. The complete opposite just might be the best way to go, actually. Imagine this situation for a second. What if I asked you to find yourself a brand new TV before the end of next month? You can tell your spouse or significant other that I made you do it. If you haven't been following TV technology in the last decade, you're in for an earful. Beyond brand and size, you'll have to consider the number of hertz, the number of pixels,
interlaced or progressive, LED, LCD, plasma, OLED, contrast ratio, number of HDMI inputs, internet streaming services,
and more. Will you remember and understand all of this new info before you analyze and evaluate? No, you'll learn as you shop. At some point, you'll see 2 similar sets with different prices and realize what the difference in hertz means, and so on. The bottom of Bloom's will stick as you play in the top of Bloom's. So, if your classroom objective is for your learners to remember or understand something new, perhaps the best learning activity is a more challenging one. To better apply something, perhaps creating is the best learning context. So if we stick to creating all the time, then everything will be learned perfectly, right? It's a trap! Again, the challenge must fall within certain limits. This is where Vygotsky's zone of proximal development comes in. Lev Vygotsky was a Russian psychologist with interests in developmental psychology, child development, and education. In a nutshell, the zone of proximal development can be explained as follows. Say this represents what you know, things you've mastered. Any task we ask of you that stays within the boundaries of this might be perceived as predictable, non-engaging, tedious even. This is the limit of what you can learn on your own. Learning activities that play out in this neighborhood will seem challenging. They might require collaboration or help, but they remain accessible. This is the zone of proximal development. Go way past this limit and the challenge is too great, and the learner gets discouraged, opts out, or drops out. Obviously, the ZPD is different from one person to another, and what falls into each region evolves as one learns. Now, what if we take this reasoning and merge it with our view of Bloom's taxonomy? We get 3 discs. This is what you've already memorized, understood, and know how to apply. This is within your reach. With some help, you could understand, apply, and eventually memorize this, but this thing here, that's just way too hard at this point in time. On this level, these are the strategies and processes you know how to use for analysis and evaluation. Side-by-side comparison, for instance, or peer-weighted pros and cons lists, setting up focus groups, research skills, etc. Again, these strategies and processes are new, but just within reach. These require some collaboration or coaching. As for these, you're simply oblivious to at this point in time. On the creation level, the innovative skills and competencies you've mastered can be found here. Things like mix and match capacity for abstraction, inspiration catalysts, problem solving, and other creative strategies and processes. You can also fit the magnitude of the creative endeavor here. Again, yes I can with a friend, and yes I will if you give me a couple of years. Now I can't prove what I'm about to say, but my colleague Judith and I think it's an idea worth exploring. So here goes. When we teach, we have a learning objective for our students, the targeted learning. To help students hit that target, we try to offer the best means to acquire this new knowledge or skill. That's the ideal learning activity. The targeted learning should fall within the learner's zone of proximal development, somewhere here. No point in targeting what the learner already knows, right? And we think the ideal learning activity should mobilize already known or mastered knowledge and skills of another level of Bloom's taxonomy. Think about this for a second. If you want to develop a new analysis or evaluation strategy, perhaps it's best for you to be relatively familiar with the data. This way, you can see if your new strategy is working and not be bogged down by data you don't understand. If you're going to create something with this new analysis or evaluation strategy, it's probably going to borrow from things you're already comfortable creating. You can probably see the flip side starting to peek its head here, right? If the learning activity falls into your zone of proximal development, chances are this will become the focus of your learning at the expense of the targeted learning. For example, let's say the class assignment is for everyone to create a multimedia presentation where you present which form of government you consider best between parliamentary and congressional. Phew, tough class. The teacher's target was to help learners understand the differences between both forms of government. The main task is an accessible analysis and evaluation exercise instead of asking everybody to memorize the stuff. That's great. But what if the communication strategies and the software know-how that's needed to create the multimedia presentation represent a challenge as well? Learners might end up spending more time refining their communication skills and exploring the software than actually learning about both forms of government through evaluation. But if the learner is comfortable with the software and creating that type of communication, then the task was perfect. Different learners, different ZPDs. Do you see how technology can be friend or foe here? Unless you're giving a computer science class, technology should not be the targeted learning per se. As for ideal learning activities, technology makes an amazing creation tool. It's wonderful for analyzing and evaluating because it can help you organize the information and see it from many different perspectives, and it's clearly unavoidable for reference nowadays. But it's also very important to take into account that different learners will have different ZPDs. There's no reason to ask everyone in a classroom to produce the same thing the same way using the same tools. The same target, yes, of course. Same way to get there, why? Standards are important. The way to reach them doesn't have to be standardized. I hope this little homemade theory of ours can be helpful for your didactic practices. Try analyzing different learning activities and scenarios using this Bloom and Vygotsky hybrid cylinder. Reflect on whether or not the targets and activities are the ones you intended. Enjoy!